Also up here at the beginning, when you see f at c equals k, that's just talking about an ordered pair, c comma k. That's all it's talking about. It's just an ordered pair. So we have a lot of things dealing with just some ordered pairs, just some points on a graph. Now, if we have this a value here, and then I'm going to put another point somewhere up here. And so the coordinates of that point, I'm going to call that f at a. Okay? It's just going to be your y value at a. All right, so then the next one, we've got a b value. And somewhere along here, I don't know, let's put it down here. We're going to have f at b. Now we're told that this function is continuous. So that means between a and b, there's not going to be any kind of breaks. Now does that imply that the graph is going to be a straight line though between a and b? No, it doesn't have to be a straight line, but we do need to maintain that it is a function. So when I go through this, you can connect these however way you want to. And you can make it a straight line, or you can make it look something like this. Or you could go, you could even do something like that. You can even make this curved. It's not going to matter. You just need to connect them. So you could do something like that if you wanted to. The whole point of it is, though, that you are connected there. Okay, so again, y'all go through and connect it however you want. Doesn't really matter. And so here, what I'm going to end up doing with this, after you go through, some of y'all going to have to move. Don't distract each other. I'm going to listen to it today. Smack you through a wall. All right, so we've got f at a, f at b. Is it safe to say that f at a and f at b are two different values? Yes. Yeah, it's pretty safe to say they're not equal. So what we're going to develop here, we're going to say, well, there's some k value through here. There's some k value that I'm given. And that k value is between f at a and f at b, isn't it? It's somewhere between it. Y'all good with that? Okay, so we know here k is between those. So if we're continuous, what has to be true about my c value? Where has it got to be? It's got to be between a and b, doesn't it? That's all this is stating. If you're a continuous function on a closed interval and somebody gives you a y, you're guaranteed an x to go with it. That's all this is saying. So here, the statement that you can make from this, you're going to say, well, there has to be a c. Where's that c located? That c is between a and b, isn't it? There's a c between a and b, so that f at c is equal to k. Okay? And again, as far as your graph, you can draw it any way. Just maintain that it's a function. It can be a straight line. It can be curved. It is up to you. Just connect the two dots, however. Now, does this make sense? If your graph doesn't have any holes in it and any asymptotes, and on that interval, I give you a y value, you're guaranteed an x value. That's all this is saying. This one is called the existence theorem. Let's look at another. Through this, it showed us that we just had a and b above the x-axis. Nothing says that a and b have to stay above the x-axis. So look at you write this. And again, I'm just going to draw a graph, but earlier, whenever it happens, if I move b below the x-axis. So again, I'm still going to have this a value, and I'm going to have maybe f at a up here somewhere. I'm going to call that f at a. And then over here I've got b, but I'm going to want to put f at b somewhere down here. I'm going to call that f at b. I'm going to put it somewhere below the x-axis. Is that okay? All right, now let's connect the two. What is going to happen if we are continuous? What happens to my graph there? It has to cross what? It has to cross the x-axis. And if I wanted to label that a point C, if I wanted to call that point C, the coordinates of that would be C comma what? 0. C comma 0, right? So that's going to be a useful way for finding zeros of a continuous function. So you can establish zeros of a continuous function. Now, we're not actually finding the actual value of the zero. We're just saying the possibility of it does exist, which really in the long run doesn't do a whole heck of a lot, but it is something we need to know. All right, so it makes sense if you've got a y value above the x-axis and a y value below the x-axis, and you connect the dots, you're going to have to cross the x-axis, right? All right, let's see how. So the very first part of this, you're looking for an ordered pair so that you have C comma 1. And even though I drew this out, I was looking back here, but there's really one right here, isn't there? So is there a C value inside this interval so that you have a Y value of 1? The answer is yes. Yes. If you look at the right place on the graph, it's going to be there. Awesome. But look over. Y'all stop whispering, dear goodness. I'm going to put you on a seating arrangement. Y'all are 18 freaking years old. All right, now over on the other side. Does the intermediate value theorem guarantee this is going to happen? And the answer is no. And tell me why not. Okay, the function is not continuous. Over what interval? You've got, there you go. You need to make sure you write in not continuous over that interval. You can't just state not continuous. Now, I've cleared up my mistake, I hope. Are y'all better now with it? Yes or no? All right, let's do another one. All right, so is there a value of x equals c on the interval from 1 to 6, and look over the whole interval, so that g as c is 3? No, but what about all the way back here, though? Look over there. Oh, it's not in the interval, right? All right, so the answer is no, right? Okay, what about over on the IVT part? Does the IVT guarantee that value? The answer is no, and why not? Your function is not continuous. Is that okay? Is that great? Cleared it up. All right, so do make sure the function, when y'all say the function is not continuous, make sure you put it over the interval, because we can restrict that interval, make it smaller, and it would be continuous, and the IVT could support a particular value there. So you have to be careful.
Is it not continuous?
All right, let's write that. The graph must be continuous. Y'all rock and roll. So here, the first thing, f of x, the function must be continuous. But you've got to tell where. Don't just say continuous. I'm going to mark it wrong. Must be continuous on a particular interval, and we're going to make that from A to B. Got to be continuous on that closed interval. Now, what else has to be true? What else? That particular value that you're looking for, that f at c value, must be between... What two things? Must be between f at, not necessarily just a and b, but f at, because if you're talking about f at c, you're talking about y values. So f at c must be between f at a and f at b. That has to be true. Continuous, and your y values got to be between your f at a, f at b. Questions? Questions? Okay, let's do an example. And this is how we are going to use the intermediate value theorem. This is how it will be supported. Very first one. Apply the IVT if possible. So let's stop there. Notice where it says if possible. Y'all, in your other AP classes, especially with history and English and several others, they'll be like, okay, you're going to get some parts that you're not necessarily going to use. That's never the case in calculus. When you have a free response question and you're at the end of that free response question and you've not used every bit of the given information, something's wrong. You will use everything. Every part of the statement has a purpose there. Every one of them. So here, even where it says if possible, apply the IVT. As soon as you see if possible, you better go through the statements of IVT. What is the first condition for IVT to work? What has to be true? What is it? F of x, the function. F of x must be continuous.
What if you said just the function must be continuous?
The function must be continuous, or f of x is continuous. It's fine. They're interchangeable, but we have to nail down the interval, though. It's got to be continuous over 0, 5. Okay. Now, something for us to realize here, we're given a nice polynomial. We know the shape of that. Okay. All polynomials are continuous. All polynomials are continuous. So I would write that as a note back to yourself. All polynomials are continuous. Important for you to know. So now I've got the first part of IVT satisfied. I have a continuous function over the closed interval from 0 to 5. What was the second thing that had to be true? F of C must be between F at A, F at B. What are A and B in this problem? Perfect. So F at C must be between F at 0 and F at 5. Well, y'all just about got it finished. Yes, sir.
What's the difference between f of x and f of c?
You're given a specific value of C. C is narrowing it down. F of x is in general. F at C is at a specific value. Okay. So what do we need to go find? F at 0 and what else? F at 5. Go find those values and show that your y value is between those. Yes? So let's see. What is f of 0 equal to? -1. What is f at 5 equal to? 29. So is it safe to say that f at c is between f at 0 and f at 5? If nothing else, and y'all, I encourage you just to do a little plot, point plotting here, just to make sure you kind of see what's going on. 0, -1. That's going to sit down here somewhere, right? Unless my cracks kicking again. Did I put it in the right place? All right, what about 529? That's going to be over and way up here, right? Okay, so there's 529. And down here was what? 0, -1. So I've got this area right through here kicking. So what I want to know is, is there a value so that f at c equals 1? In other words, right here's 1, isn't it? If I were to connect these dots, would I have a value right there? Yeah, because I'm continuous. So here, how are we going to make all that written statement? How are we going to write it up? Well, you're going to show, and you just did, that here your f at c value is between f at 0 and f at 5. So you would say f at 0. Which is going to be less than what? F at 5, isn't it? So So your f at c value is between, do y'all see that? Yes, no, maybe? All right. So does the intermediate value theorem support that there has to be a c value? Yes. You are continuous. Your y value is between your other given y values, so there has to be a c to go with it. Let's try another. Okay, so first thing, is our function continuous?
Yes.
Yes. So what would you need to find next? Good, your y values. What is f at 0 going to be equal to? -1. What is f at 1 equal to? 2? Maybe some days. Don't y'all think it's 2? Okay, whew. Y'all my skills brushing up too. All right, so let's see. Let's plot these 2 points and see what happens. We've got 0, -1. We have what? 1, 2. Is our function continuous? Yeah, so what's going to happen if our function's continuous? We're going to cross the x-axis. So are we going to have a 0 there? Yeah, so there has to be, because here that's going to be the ordered pair, what, c, comma, 0, right? So how in the world are we going to write that up so that we prove it? Well, one, we have a polynomial, right? So we're going to say f of x is continuous on the interval from 0 to 1. Now, there's no way you'll be able to get full credit if you don't do the right write-up for the free response. It's very important that we give that. So number 1, f of x is continuous from 0 to 1. Now, what was the second thing we established? F at 0 was -1, wasn't it? And what was f at 1? 2, right? And we're also seeing the 2 endpoints. F at 0 is not equal to f at 1, right? Just going for the gold there, saying, yep, all that is satisfied. All the steps are satisfied.
So is all of this the answer? Or
Yes, and every bit of it's the write-up. So the last part, what are you going to state about it? So notice that f at 0, that was negative, right? So we can say that was less than 0. And what is f at 1? F at 1 was greater than 0, right? So by IVT, intermediate value theorem, what has to happen? There must be a c, right? So that f at c equals 0. All right, so we're just asked whether or not there's a t value. So right here's our t value, and think about that as your x, and this is your f of x, if you want to think of it that way. So is there a t value from 0 to 60 so that there must be a time t so that the velocity is -5? Yes or no? Yes, you're right. There should be. Now, how are we going to justify all of that, though? Because we can't just write yes and get our 9 points on free response. What do you have to establish first? Now, think about, we're just talking about existence of a value, so that is still intermediate value, right? Is our velocity function continuous? Is the velocity function that we're given continuous? Everybody's like, I don't know. Read the problem. Y'all, every part is going to be used. Every part. What does it tell you first thing up here? Let's see, continuous function. What are the units? Feet per second. What function am I given? Velocity. All of that is important. Every bit of it. Every last bit of it. So whenever you go to write this out, you can say, well, you know that v at t is a continuous function, right? Is that okay? V at t is a continuous function. So around what area does it look like our velocity could possibly be equal to negative 5?
40.
Somewhere. Now, do we know 40 for sure? No, we can't make assumptions. We know what that does. We know that it's probably going to fall somewhere in that interval, right? Is that agreed? Okay, so what statements can we make there? Well, I know that V at 35 is negative 10, right? What do I know V at 50 is? 0. And we know that negative 5 is going to fall between negative 10 and 0, right? Does that make sense? Okay, so we could even put that. We know that negative 10 is going to be less than negative 5, which is less than 0. You can write it that way. You could even, state that V at 35 is going to be less than V at t, which is less than 0. You could write it that way. As long as you're using the context of the problem, you're good. So since you know all of that, you can say there must exist now, what are we trying to prove? Don't go back to the C, because in the context of the problem, what variable do we have? T. So there must exist a T over what interval? So where is that interval going to be? But it go back over here to here, right? So that, and just restate the question. V at t equals negative 5.